Hi all, welcome to my channel. When I take trainings for data science and machine learning or I deliver some webinar, many times I also write answers on Quora, Stack Exchange, ResearchGate, and on my blog. I also create content on my YouTube. Many times I see that people approach me one-on-one and they ask me about how to study mathematics or statistics required for data science or machine learning. And specifically, these queries are from those who have never done math before or from those who have done some math in their degree but they are not very comfortable with those concepts, right? So if you are looking for making your foundation strong in the area of data science or machine learning, you need to practice linear algebra, calculus, probability, statistics, these things. But if you're not from this background, it's okay. You don't need to do a lot of heavy math. You just need to understand the concept. And if you have chosen to understand those concepts, you are at the right place. So in this series of video, we will talk about linear algebra. Linear algebra, you might have heard about this name. When you hear linear algebra, what comes to your mind? X, Y, Z, fancy polynomials, sin x, cos square x, tan x, log x, e raised power x by 2, something like that. Equations, system of linear equations where you have multiple equations in multiple variables, you want to solve that. Optimization where you want to optimize a particular loss function, error function based on one or more than one conditions. Vectors, matrices, etc. And those who don't like math usually get scared thinking about these topics. And those who are from non-math background, they really find these things terrible. So I will try to make these things simple for you. Now, when you choose to decide any particular area of mathematics or statistics per se, whether you are willing to strengthen your concept of linear algebra, whether you are learning calculus for the first time, or you are doing it as statistics, probability theory, inferential statistics like hypothesis testing and so on, whatever area you have chosen to study, first of all, you need to take a pause and you need to think, what do you want to study? How do you want to study? And why do you want to study? Many students ask me the resources to study these things. They ask me for a particular book or course or video, or they ask me like I really don't get it. I have tried doing it from multiple sources but I don't get it. So let me advise you one thing, that if you have decided to study a particular topic, for example linear algebra, it may be any other mathematical domain, first of all you need to understand that there can be different approaches to study that topic. There can be different approaches to teach that topic. One approach, which is the textbook approach, is like you studied from the textbooks where you read the formal definition of each and every topic, you read the formulas or you read the derivations, you do the computation or derivations manually yourself by taking paper and a pen. This is the approach which usually the mathematics students apply when they learn a particular subject. Like when I was doing linear algebra in my post graduation, I used to study it from textbooks where there were formal algebraic definitions and their derivations. Each and everything was written in terms of mathematical symbols and all those derivations kind of thing. Even when I have studied statistics in my MSc in MPhil, it was not the statistics which you study in your data analysis or data science or your PhD research. It was the statistics heavily based on the derivations, like you compute the derivations for mathematical expectation, moment generating function, and many such things, right? So mathematics students do study these things and it gives them a strong foundation, right? I never needed to remember a formula, right? If I need to do Laplace Fourier transform, if I need to do statistics or anything, I never remembered or tried to remember any formula because I used to understand the concept and I was really enjoying to derive those things myself. So this approach is suitable if you are a mathematics student or if you are preparing for a particular math exam where you need to do derivation computations manually yourself. For example, you need to compute the regression coefficient yourself manually using a paper and pen. You need to do simplex method to solve the linear programming problem yourself. You need to do matrix multiplication and inverse of a matrix yourself. You need to apply Gauss elimination, row reduced echelon form yourself doing paper and pen. Then this approach is applicable, right? But the good thing is, if you are not a mathematics student and you don't want to go to that much depth and you don't want to do this much calculation manually, you can skip doing these many derivations and calculation. Particularly if you are doing it for data science, machine learning, or if you are a physics student, you want to understand linear algebraic concept to be applied for quantum mechanics, physics, something like that in engineering subjects also, then you need to have the understanding of their concept, their intuitions. What do they physically mean? What is their geometrical interpretation? Is there any intuition or interpretation for that particular thing? Or how can you relate it to real world cases in your particular areas or domain? For example, eigenvalues and eigenmatrices, these are abstract concepts when we study the definitions in linear algebra. But how eigenvalues and eigenvectors are important, how you interpret these and how you can relate it to your areas where these are applicable, that would be more appropriate approach for you if you are not from math background, right? Another thing is, if you are a coder, there are many programmers these days who are switching to technical areas without any math or stat background. And if you are a programmer, you might find it easy to understand the things if you look at the R code or Python code or something else. There are many other tools. There are some tools specifically designed for linear algebraic operations. I'm not talking about all those solvers here, but popularly R and Python, everyone knows who is coming to data science or machine learning, right? So if you feel that I can't even relate to the geometrical meaning of these concepts and I can't even understand what you are trying to say by looking in the three dimensions, understanding the area of the parallelogram or volume or something like that, I can't really relate to it. But I can understand the codes. It's okay. If you can understand the code, you need to implement these things in either R or Python or any tool of your choice so that you can see the output there, that you are doing certain operations and you are getting this output, how you can manipulate it. And probably there you will develop an understanding of basic linear algebraic operations, if not in depth, right? So we will see in this series, we will talk about the intuition. I will give you little bit of math here and there because I am from math background, so I have a habit of doing some math in between. But I will not make it very math heavy. If you want me to do a certain thing in mathematics, I can think of doing it in a separate video. R and Python implementation, again, if you want me to do it in either R or Python or both, you can let me know. I will see if I can create videos on that also. Otherwise, it's very simple. In R, matrices are their inbuilt data structure. In Python, you can do it using NumPy, or there is one more package, SymPy. So using those packages, you can do these kind of calculations, which we will be understanding. I will be giving you some hints as we will move forward in the course. So stay tuned. Thank you for watching.